The solution we are presenting today is called ABiC, which could be your strategic data intelligence partner. As I briefly mentioned, ABiC, our autonomous business intelligence clerk, helps companies work with data and make better decisions. Normally, to get insights from data, you'd need IT knowledge or expertise in statistics. But with ABiC, that's no longer necessary. All you have to do is ask a question in plain language. ABiC understands your interests and intentions, then shows a clear dashboard to guide your decisions. With ABiC, complex data is autonomously analyzed and turned into answers that support users, helping to accelerate business processes. Before we get into the demo, let me explain the background and scope. In hospitals, EHRs and many other departmental systems run every day. Each system has its own analysis functions, but the information you can get from a single system is very limited. The information you really need comes from collecting and analyzing data across multiple systems, like RIS, attendance management, medical supply inventory, and instant reporting. And most hospitals don't have specialists like data scientists who can handle this kind of work. That's where ABiC comes in. ABiC reads requests in natural language and shows the results on a clear dashboard. This means non-IT staff can analyze data anytime from anywhere. The demonstration we are giving today focuses on intelligent queries and AI-assisted analysis. Collecting data from multiple systems is outside the scope of this demo. This story is about Mr. Kitano, the Director of Administration at Tokyo City Hospital, a medium-sized hospital with around 500 beds and an emergency room. Last year, in April 2024, a large outdoor music festival was held in the area where the hospital is located. The city has decided to hold the same event again this year, which is just a month away. During last year's festival, the hospital faced several challenges. For example, the number of ER patients at night was higher than expected. Mr. Kitano wants to make sure the hospital is fully prepared this year. He is aiming to manage and coordinate everything carefully so the hospital can handle any issues that may come up on the day of the event. However, Mr. Kitano is facing a very challenging situation, which can be compared to the Swiss cheese model. Accidents in the hospital rarely happen in isolation. They usually result from a chain of events. One of the main factors is staff shortage. With fewer staff across the hospital, each person is working more consecutive days and night shifts, making it harder to take time off. At the same time, the higher workload for each staff member means that human errors could happen at any time. To prevent accidents before they happen, it is necessary to analyze all available hospital data to understand the situation from past to present. However, currently, hospital data is siloed within each system and not aggregated in a single repository. Before we can collect and analyze data, some preparatory working is needed, such as standardizing it. Unfortunately, there is not enough budget to make this possible. With both staff shortage and limited budget, hospitals may want to improve working conditions, but it is difficult to identify practical solutions without a clear understanding of the current situation. That's why we propose our ABiC. Now, to show its capabilities, I'll hand over to our team for the demo.
Let's start the demo. This is ABiC chatbot. Enter the question in the bottom left corner and click the ABiC icon to start processing. Let's try it out right away. Tell me the number of incident reports by fault level, continuity, and number of incident reports in April in 2024. ABiC uses a retrieval augmented generation RAG approach. It sends users' questions together with relevant InterSystems BI cube context, such as measures, dimensions, and listings to an OpenAI model to generate answers. When ABiC is ready, the analysis summary and recommendation for the next analysis will appear in the chat box on the left. This is a summary, and this is the recommendations. Let's confirm the analysis result. The dashboard is created based on the question. The dashboard is filtered by the specified April 2024. We can see two reports in this. Let's check the report, which department, who is in charge, and what the disability level is. Incident reports occurred on 9 April, close to last year's event dates. The doctor is Dr. Dean. And the report appears to have occurred while working in the ER. Let's move on to analyzing employee attendance around April. Tell me the number of employees by role working nights and days in April in 2024. Let's check Dr. Dean's attendance information. I choose Doctor cell and drill through this cell to get original data. I can check Dr. Dean's attendance. It seems he is very busy in April. He has a lot of day and night shift and long consecutive days. Let's move on to the next analysis by selecting a question from the recommendation. Make use of the waiting time and let me explain how OpenAI interprets cube context. I will also explain what is included in the system prompt sent by ABiC to OpenAI. First, let's take a look at the BI cube context provided using RAG. InterSystems BI has a lot of REST APIs and utility methods for getting information on measures, listing, and executive pivot result, etc. In this demo, I use these REST APIs. Measure definition regarding the specified cube, and listing, and dimensions. We can see the cube definition on the management portal like this. Let's look at the actual payload ABiC sends to an OpenAI model in our RAG workflow. I run this method. In this method, I prepare cube context in JSON. Since this is fixed context that will not change until a new cube is created, it is set as a variable in the configuration file config.py, the JSON returned by the REST API in Iris. For your information, this REST API uses Whiskey. Here is a BI context. Next, ABiC sends the pivot result to an OpenAI model as context in our RAG workflow. Once again, we can use a BI REST API to obtain the analysis returns by specifying the pivot name. I'll use a debug global to check what kind of context being sent. This is a pivot result. The context and summary requests are sent to OpenAI as system prompt. Back to the ABiC chatbot. We can also see the third request result on it. Since the data used in dummy data, it may not be possible to perform the analysis proposed by OpenAI. In addition, although we are using an existing cube this time, providing all the table information that can be used for analysis to the generative AI and creating the cube using ABiC will enable us to provide a more flexible analysis environment in the future. This will be an improvement to this demo in the future. That concludes the ABiC demo.
I'd like to explain the architecture for real-world deployment. The virtual agent, ABiC, receives users' questions in a natural language. It then sends the questions along with metadata of InterSystems BA cubes to a large language model. This is done using Retrieval Augmented Generation, or RAG, where the cube metadata provides context for the LLM. The LLM provides detailed analytics, including the MDX queries needed to generate pivots and dashboards. ABiC then uses these suggestions to automatically create the visualizations. Next, the agent sends the analysis result back to the LLM. Using RAG, the LLM retrieves relevant information from external sources and references it. It then generates a summary of the analysis and provides recommendations for the next steps. Finally, the user can interact with the dashboard to see summary of the analysis